Thank you all for coming to Weather Watch March 22nd. Could we pull up the current satellite please, Pete? This will be a little abbreviated because we're all on spring break already in our minds.
And basketball.
And basketball and
How's
snow.
everybody's bracket doing?
What?
How's everybody's bracket doing?
Well, just like the snow forecast. You know.
2 games.
I picked the Oakland game after it was over.
I think
So
that
look-
counts.
Looking at the
Should.
current satellite, we kind of have two areas of clouds for the eastern United States. First, there's a nice cyclonic circulation to the southeast. You can make out maybe there's a center to this circulation over Louisiana, Mississippi. And then there's another cloud band that's kind of harder to see with lower clouds, but that's moving through our region. And that's our snowfall. It's not tied to whatever this is down in the southeast. It's a separate feature, came from Canada and northwesterly flow. And is bringing us our snowfall, and you can see on the back side of it, this is all just clear snowfall over Canada. And it's highlighted by, you can see a couple lakes. Treetops and mountaintops are the bright whites, and then the speckled is in between all the pine trees up in Canada. And then you can see some snowfall. In the northeast, Maine and Vermont had an area of decent snowfall from this low pressure system. It kind of sat over northeastern United States and southeastern Canada for a couple days and brought snowfall, which you can see highlighted in the brighter whites over that region as well. So main focus will be, why is it snowing today? Other than it's still March, we can still get snow, but what is the main driver of this band of snowfall that is decently heavy over Iowa and northern Illinois this morning? So could we go to the 300 hectopascal super peak, please? So we'll get a look at the jet stream first. And we can notice two regions of enhanced winds at the jet level. So one is tied to this feature that's stretching from the northeast all the way into UP of Michigan and back into Minnesota. And then there's another one that stretches all the way from basically Hawaii into Mexico and Texas. So these are two main features that we can look at, investigate. What kind of jets are they? What kind of weather they might be bringing? But you'll notice they're kind of far removed from where we saw areas of circulation and precipitation. So I wouldn't expect them, just from this look, to be too influential on our snowfall and rain, which is happening in the central United States, well away from both of these features here. So we'll keep an eye on the Michigan one into the northeast first. Could we go to 250, please? So it's in the purples, and you'll see it kind of decreased in magnitude as we went higher up in the atmosphere. Could we go to 200, please? And you'll see the feature kind of completely falls apart. So this is a polar jet stream. It's stronger closer to the ground due to the lower thicknesses, and then it weakens as we go north. The same thing, I won't do it because it's not a feature of the talk right now, but this is a subtropical jet stream. It got higher, it got stronger as we moved higher in the atmosphere. So polar jet streak over our region and subtropical jet streak over southern United States. So one thing to consider is the polar jet stream sitting right over our region, indicative of the colder air that might be a factor into our snowfall here.
Incidentally, we're getting close to, we're 3 weeks away, Libby, from the middle of April, and look at this, no polar jet anywhere over North
That's right.
America at 200 millibar.
That's right. It's just this little area. Everything else subtropical. Could we go back to 300? I'll just point that out again here. So this was the only polar jet streak anywhere on this map, all the way into Canada too.
Yeah,
So,
then you get the little thing that hits the Greenland tip, but that's it.
Yeah,
That's the
that's
only
right.
thing. Boy,
That's right.
amazing, isn't it?
So here's our polar jet streak. Could we go to 500 now? So we might look at maybe there's a trough impacting the region, leading to upper level divergence, rising motion. Over our region, not really anything. Mostly zonal flow. There's a little bit of speed shear, but not too strong over our region. The main baroclinic zone is well to our north and west at this time, 7 a.m. And then the feature down in the southeast definitely tied to a weak but definitely apparent trough, and the circulation was exactly where we expected, right downstream of this trough feature. So over our region, zonal flow. So this is indicative that this is a completely lower level feature this snowfall, because we don't have anything 500 and above that's really affecting vertical motion over our region, bringing the heavy snowfall. So could we go to 850 now? And we'll see, here's the reason we're getting snow. So if you focus in Nebraska, Iowa, Illinois, there's a very tight baroclinic zone right over the exact region we saw our snowfall. And look at the wind. We have, this is Davenport, Iowa. We have southwesterlies. And then in Minnesota, Minneapolis, we have northwesterlies. So there's a nice convergence zone right over this baroclinic zone, which means we're strengthening the temperature gradient. We would expect the response to be rising in the warm, sinking in the cold. We're sort of in the colder region of this baroclinic zone, which might explain why our snowfall has kind of been, pretty weak comparatively, and smaller flakes. But right into Iowa and Illinois, where we saw the stronger snowfall, that's exactly where you have warmer temperatures, stronger convergence along the baroclinic zone. That is here's your snowfall. And this exactly matches where the band of frontogenesis has set up, creating the snowfall, and where we have 6 to 12 inches forecasted, where we, earlier in the week, might have been in the heavy snowfall. That area shifted just to our south. So this is your snowfall, this frontogenesis zone in the lower levels. Everything above it not really affecting it, and we're just to the north of where we might see heavy snow from this feature. And there might even be, now that I'm looking at it, some lower level trough. I don't know how reliable that is, because there's only one height contour in the middle of this, but there is a wind shift too, so maybe there is some upper level divergence, or I should say lower tropospheric divergence, because we're at 850, but mainly the frontogenesis in the lower levels. So I'd say it's the region we're seeing this snowfall. And then could we go to the surface, please? And so it's been snowing all morning, and we'll see that reflected in the obs here. So here's exactly where we saw the baroclinic zone at 850 and where it's snowing. At this time, when it was Milwaukee, this is Rockford, and then Davenport are all reporting snow. Temperatures right around freezing, so areas that are seeing the heavy snow are probably seeing very heavy flakes, very big flakes. And then we're not reporting any snow, but it's been this light snow that's just falling, not really accumulating. And it has been doing that for an hour or two now. And you can see some haze reported behind where the snowfall has fallen. So maybe it's already beginning to melt in Iowa. That's why you see this haze being reported. And then there are winter weather advisories for our region, northern Illinois, and then stretching almost exactly in a line into Michigan and Indiana and Ohio. So right along the baroclinic zone at 850, exactly where we're seeing our snowfall.
Moderate snow at Detroit, look at that.
Yeah, that's right.
Or not Detroit.
Yeah.
Where is that? Is that
Ann Arbor, maybe?
Yeah.
Or Lansing or something? Yeah. So, unfortunately, we might be out of the heavy snow, or fortunately, because it's spring break coming up, so maybe we don't want snow, but looks like we're about done with our snow, and areas to our east are going to be affected by this snowfall. And then you can see right on its heels, it's going to get colder tonight behind the snow. Clearing, you see very low dew points, some below zero, so that's your lower limit of cooling. So we might see areas in the single digits, maybe close to zero. Northern Minnesota, and then I believe we're supposed to be in the teens tonight. Once I wouldn't call this a dry line, but lower dew points being ushered in behind this snowfall here. And honestly, we can also focus on southeast real quick. Here's our low pressure center, not really too well-defined warm and cold front, but there is cyclonic circulation and some rain being reported with that as well.
That may be the worst frontal analysis I've
I
seen.
know.
Don't turn away like that.
It's kind of a nice embroidery pattern, but it's not a frontal
Unless
analysis.
you have a really good reason for it.
Yeah.
Anyway, you can explain it.
Right. Yeah, this triple point right here, this is where you want to be storm chasing,
Yeah.
because they was. But that's all I have. And all my comments on the current snow.
All right, thanks, Patrick.
Yeah.
This will be a perfect segue. Can we go to the QG Omega page that I see? And this is, I haven't looked at it, but I have an idea that I think I want to see if it's verified. Yeah. So let's go to the 12-hour forecast of the total omega. This is at 700 millibars. It's only one level. It's not a fancy web page, and of course it's not working. Let's try the 12Z on the bottom and see if we can find it. You gotta scroll down. It's not. Alicia, if you're watching, sorry. This is not my thing. Look, gotta go to 0 hour, because that'll be 12Z this morning. Let's see what it says. Okay, so this, unfortunately, really kind of boring picture of the vertical motion, except if you're over Maritime Canada. This is the one that's responsible for our snow, of course. And I hope that the values would be a little larger, and if I were doing it manually, I'd make them larger by changing the contour interval, and then splitting it up. So let's see what the pieces of this look like. Patrick mentioned correctly, I think, frontogenesis, so let's look at the transverse omega. And at 700, it doesn't show up at the contour interval, because it's a low-level feature. But let's go to the other one. I suspect then the most of it is, yeah, right there, the shear-wise omega. So this is, you can see this is partly a portion of that total that was over our region. And the shear-wise omega is forced by a long isentropic convergence of the Q vector. And so it occurred to me today, that piece of the quasi-geostrophic forcing is composed of PVA by the thermal wind and a non-frontogenetic deformation piece. And the deformation terms only start acting when there's a second derivative of temperature, namely a thermal ridge or a thermal trough. So I don't have a use of the blackboard. This moves on glacial timescales, if I remember right. So let me just show you what I'm thinking. With some chalk, I need chalk.
Here's some chalk.
Thanks. Yep. So it looks like, from what Patrick showed us, there is a set of isotropes that look like this, colder and warmer, and then the Davenport wind was kind of straight through these isotropes. I think straight, really strong warm advection. And then weaker warm advection adjacent to it, and weaker still over here. In fact, it might have been a different sign entirely when you get into Minnesota. But this is an idealized picture of a localized maximum in warm advection. And when you look at that, you can figure out what the Q vector is at these 2 points, because it's A cross dBGDS times dTEN. That's the natural component form of the Q vector. So all you have to do is assign what is the geostrophic wind difference at this point, and you're going from a small one to that one, and so that's dBGDS there, and here it's the other way around. And if you take the vertical cross product of those and then flip them, you got a Q vector that's like this at that point, and a Q vector like this at that point. So it's a long isotropic Q vector convergence, which means it's either vorticity advection or deformation. And I thought, wait a minute, this doesn't look at all like a vorticity advection picture. And that's what I was thinking about this morning. I was kind of puzzled by that. And then it occurred to me, no. It is. Because look at, if you imagine an air parcel centered on this X, it's going to be spinning like that, right? Under the influence of these two adjacent horizontal winds. This one is going to be spinning like that. So here you've got positive vorticity, negative vorticity, thermal wind going this way. It is a region of PVA by the thermal wind. It has to be, because the only other option is it's a non-frontogenetic deformation, but in the absence of a thermal ridge, you can't have that happen. So this is a weird low-level PVA by the thermal wind feature. And this, I think, has relevance for what we're talking about with your storm. It's another way to think about this seemingly innocuous and not quite, canonical picture of a vorticity-induced circulation. But I think it's right. So anyway, that's what I wanted to add to what you said. Because you're right, I think it is the combination of frontogenesis, which at 700 millibars doesn't show up, it's too low. And that's the only thing I have on that plot, but you perfectly diagnosed it. But in addition, there's that going on, by virtue of the nature of the wind arrows across the isotropes, which are pretty much straight across. There's no thermal ridge or trough in those isotopes. After the day goes on, this is going to start to rotate these adjacent baroclinic zones, because this is the Q vector, and Q is, of course, the rate of change of del theta following the geostrophic flow. So on this side of the axis, you're going to rotate these isotopes so that, let's see, del theta is this way, if Q is that way, the new del theta is going to look like that, and the new del theta is going to look like that over here, and so you're going to have creation of a thermal ridge. Once that happens, well, then the deformation can start to play a role too in reinforcing this vertical motion. But it can't right now. So anyway, that's what I was thinking about today. And it's in line with what you were saying about the diagnosis, but there's a little wrinkle that I think is worthy of exploration, maybe particularly in light of what we're seeing in your case.
Yeah.
So.
Okay.
So that's all I have. Spring break's going to be kind of a dismal week, weather-wise, but a glorious week work-wise, because it's the time where I know you'll all spend catching up on everything you haven't done during the, no, I know you won't, and you shouldn't. You should get out of here and don't look back for a week, and then come back and finish off strong. So that's all I have.
Okay.
So thanks again, Patrick, Pete, thank you for coming in and setting us up, and thank you all for coming. We'll see you on April, whatever it is, the 5th or something, I think?
If it's April 5th, I'll be in Dallas. Eclipse.
Oh, okay.
That sounds right. April
So I'm not gonna be here.
Eclipse.
Yeah.
Where are you going? Oh.
Dallas. My sister and brother-in-law live in Plano, just north of it, so we're taking Amtrak down.
Oh,
Staying
that's
with them.
exciting.
Yeah. Our whole family, my